Solving equations today. It's kind of our bread and butter. We tend to like solving equations, and we're most straightforward things that we like to do here. And so these will be exponential and log equations. And so one of the number one things that we'll do will be changing forms between log and exponential. If you feel like you're kind of stuck or not sure what your next step should be, more likely than not, it should be that you change forms between log and exponential. There's a couple other things that we can do sometimes that you can see here. Just make sure you know in this third step here, we're not dividing by log. You can't divide by log. We're just kind of matching up the inside. Just like when the bases were the same, that meant the exponents could be the same in exponential form. Same thing with logs. If you've got logs with the same bases, we're just kind of matching up the insides there. You can't divide by log. And so if you have three of them, if you have multiple, like this down here, you can't just get rid of logs however you want. You can't divide by log. So you can only just, if it's log equals log, match up the insides. Right? So we'll start with the simple one here. So of course, we can just subtract the 1 over, get 2 to the x equals 64. And so if we're solving this by hand, we just have to figure out what power of 2 that is. So again, just kind of count on your hands. Count up how many fingers. Just go 2, 4, 8, 16, 32, and then 64. Should have 6 fingers counted by that point. So that's 2 to the 6. So x equals 6. Okay. Now on this one, make sure you realize that you're not allowed to do this multiplication right here. PEMDAS says that exponents would have to come before multiplication, so you're not allowed to do that multiplication there. What we want to do is cancel out that multiplication by dividing. So we get 3 to the x over 4 is 1/9. And so this is going to be where we want to do that trick of making both sides have the same base. So 1/9 is a power of 3. We can write this as 3 to the negative 2. So we've got 3 to the x over 4 equals 3 to the negative 2. The bases are the same. The exponents have to be the same. So x over 4 is negative 2. Multiply both sides by 4. X equals negative 8. Right, so of course you could check some of these if you wanted to. If you plug that back in here, you'd have 3 to the negative 2, so you'd have 1/9. 54 times 1/9, 54 divided by 9, that would be 6. All right. So why don't you try the next to yourself here. So this number 3 will be another exponential equation there. It does have e in there, but hopefully you can see if you can handle that. And then I haven't done a log equation yet. I'm going to let you see if you can figure out how a log equation would work. So take a look at number 4 there. And do make sure you realize that in number 4, that's log base 5 of x plus 2. So that plus 2 is outside the log function. If it was log base 5 of x plus 2, we'd have parentheses around the x plus 2, and that would be a very different equation. All right, but go ahead and try number 3 and 4. You can take a look at number 5 as well if you'd like. But number 3 and number 4, give those a try right now. So you can double check your answers here. So for number 3, we added the 7 and then divided by the 5 to get the exponential by itself. It's kind of like we're looking at this kind of like a 5u minus 7 equals negative 2. Like this e to the x plus 4 is what we're trying to isolate and get by itself. And then once we've done that, the trick here was seeing that to get 1, we need an exponent of 0. 1 is e to the 0. And so we want this x plus 4 to equal 0. Right? And then for number 4, because that 2 is outside the log function, we are able to subtract it. If it was log base 5 of x plus 2 with parentheses around that x plus 2, if the plus 2 was trapped inside the log, we couldn't, but it was outside the log, so we could subtract it. And then when you get to here, if you felt stuck, remember the rule of thumb here is if you feel stuck, try changing forms. This is the number one thing that we're going to do to solve these equations. If you feel like you're stuck and you're at a log, well then try changing the log to exponential. If you feel like you're stuck and you've got something that's exponential, try switching it to a log. Okay, so if we switch that from log form to exponential form, then it's easy. Okay, All right, now number 5 is a little bit different. So number 5 has 2 different exponential terms, so we can't just isolate it. All the other ones only had one exponential term, and so we just isolated, got by itself the exponential part. Here that won't work. All right, well here's the key. E to the 2x, that's the same thing as e to the x squared. Remember, power to a power, you multiply the exponents. So we've got e to the x squared minus 3 e to the x minus 10 is 0. So we've got something squared minus 3 of that something minus 10. This is a nice pattern there. That's a quadratic. Quadratic in disguise, I like to call them. It's where we can do that u substitution. If we make u equal e to the x, then what we've got is u squared minus 3u minus 10 is 0. This is a quadratic. Right? So then I can factor this. U minus 5, u plus 2 is 0. So u equals 5, and u equals negative 2. But of course, we didn't want to find u. We wanted to find x. So this is e to the x is 5, and then e to the x is negative 2. All right. Well, we're not done. We weren't trying to solve for e to the x. We want to find x. We got to get this to be x equals. So we're trying to find an exponent. We're trying to find an unknown exponent there. If only we knew something that had been invented to find exponents. That's logs, right? So we're going to switch this to a logarithm. Okay. Now it would be log base e, but remember in our final answers, we never want to write log base e. I mean, if you need to take a step here and to write log base e first, that's okay. But in your final answer, that log base e, we need to switch to natural log. Okay. Again, I use cursive because otherwise people are wondering what 1n is or something like that. So that's my ln, natural log of 5. All right, so there's our answer there. Okay, now take a look at this here. You might realize right now that this is impossible. This is a positive number to an exponent. A positive number to an exponent is never going to be negative. Remember, negative exponents would make fractions. So a positive number to any exponent would always be positive. So this right here has to be impossible. Okay. If you didn't see it right there, you could switch it. You could say x equals natural log of negative 2, but that would be undefined. I'm not sure if we talked about it yet, but hopefully you remember a natural log of anything, you need that anything to be positive. The domain of the natural log function is only positive numbers. You can only take the log of a positive number. So over here, we get no solution. So it's just x equals natural log of 5. Okay, so that's all the ones that we'll do just solving by hand without a calculator. Okay, now with a calculator, what we're going to do is we're going to ask you for the exact value. So remember what that means. That means no ugly decimals, no decimals that would need to be rounded. So that means solve algebraically. When we want the exact value, you have to actually solve that out algebraically yourself, but then we will also find the numerical, the decimal approximation to it. Okay. Now the reason we're going to say it like that is to try to get you to solve it algebraically, because if we just wanted a decimal, then to solve this equation, we could just use our calculators, right? We could just go in here and say 3 times 2 to the x minus 1, and then you could either graph the 9 separately and do calc intersect, or you could subtract the 9 over and do calc 0. Again, solving any equation in the world, your calculator can do it for you. You either make it equal to 0 and do calc 0, or you graph the left and then graph the right, the 9 there, and do calc intersect. Calculator can solve any equation in the world. Let's do zoom 6. And then I can do calc 0. Looks like it's between 2 and 3 there, so I'll say the left bound is 2 and the right bound is 3. And just hit enter for the guess. There we go. That's the decimal. Okay, so everybody should always be able to at least get part B correct. Okay, and on the test, what I'm probably going to have to do in the Canvas quiz is just in the Canvas quiz, you're probably only going to type in the decimal, and then I'm probably going to have to look for the exact value on your paper. So on the test, you might get 4 points right away on the problem from getting the decimal right, but then if you didn't do the algebra correctly, you might end up only getting the 1 point for the decimal. But you should always at least get this 1 point for the decimal here. We know from doing Calc 0, we should have that x is about 2.585. Okay? But that's a rounded value. Notice the approximate here. That's an approximation. Okay? This is some ugly decimal that would go on forever without repeating. Okay? To find the exact value, I've got to solve it algebraically. Okay, and so again, remember, you're not allowed to do this multiplication. Don't call that 6. Okay, exponents would have to happen before multiplication. Don't do that multiplication. Cancel out that multiplication. So we've got 2 to the x minus 1 equals 3. And here we can't do that trick of making both sides be the same base. There's no nice way to write 3 as 2 to a certain power. Okay, so you might be feeling a little bit stuck then. You might not really be sure what to do next. You seem stuck. How do I write 3 as 2 to a power? I feel stuck. I'm not sure what to do. Well, remember what that usually means this chapter. Change forms. Okay, so we're at exponential, so we're going to change it to log. And this makes sense because our unknown is in the exponent. And that's what logs are for solving for unknown exponents. Okay, so it's going to be log base 2. The base is 2. Logs are exponents. So it's going to equal the exponent. And then means the 3 has to go there. So then to solve for x, all I have to do is add the 1 over. And that's going to give me what we call the exact value. I wrote the 1 plus first just to make sure it's clear that the 1 plus or the plus 1 is outside the log. If you wanted to write it afterwards, that would be fine too. But this would often be how it would be written. And this is the exact value. Okay? This is, some people would also call it the calculator ready form. What they mean is this is a form that's ready that you could just type this in a calculator and it would spit out the decimal right there. Okay, and so this is going to be how you could check your answer. You could compare what you get from solving it algebraically with what you got from doing Calc 0, and if we did it correctly, they'll be the same. So log base 2 of 3, and there we go. They're exactly the same. So we know we got it right. No math works. Okay. All right, so why don't you guys go ahead and try numbers 2 and 3 here. Remember, we want you to both get the decimal, which you could get from Calc 0 or from typing the calculator ready form in your calculator, and we want you to solve it algebraically. Okay, it's up to you which one you want to do first, but you've got to be able to solve it algebraically, find this exact value, and find the decimal. You go ahead and try numbers 2 and 3 here. And so you can check your answers here. For number 2, subtracted the 1, and then if it feels stuck, change it to log. Again, if you need an extra step there to write it as log base e, that's fine, but don't write any log base e in your answer. I will take off a point if you write log base e in a final answer. All right? I could have either written it over 2 or put the 1/2 in front. Just make sure you realize this 6 doesn't get divided by 2. You can't make that be natural log of 3. The 6 is stuck inside a log. And so you can't touch it. You can't change that number there when you're dividing by 2. Okay? And then on this one here, divide by the 2, and then you're feeling stuck, so change forms. This time we change from log to exponential, but it's that same rule of thumb. If you feel stuck, change forms. And then you've got your exact value and your decimal approximation. One thing to notice on this one is if you use log properties, you would actually get an extra answer. Because if you made that be squared, you would have 9x squared there. And so then you would end up square rooting both sides and you would get a plus or minus. But the negative answer wouldn't make sense because you can't take log of a negative. So if any of you out there had done log properties, had used that 2 to turn it into a squared, you would just need to double check that answer there and see that when you got plus or minus, that a negative answer for x can't work here because we can't take log of a negative. The rule of thumb is kind of if you can solve it without log properties, it's better to do that. Log properties can change the domain and can cause some funny things to happen. So if there's a way to do it without log properties, that tends to be the better way. Okay. However, we can't always do it without log properties. Take a look at number 4. Make sure you realize you're not allowed to divide by natural log. Right? You're allowed to divide both sides of an equation by the same number. ln is not a number, it's a function. If you can't divide by square root, then you can't divide by log. Okay? So we can't divide by log, so what we have to do here is use those log properties. So here the addition is going to turn into multiplication. So these two are going to get multiplied together, and of course we're going to have to multiply that out. And then here, remember those numbers in front can turn into exponents. Okay. And then now you might wonder if now you could divide both sides by log, and you still can't divide by log. You're never allowed to divide by log, but we can get rid of the logs now. Okay? We can say if natural log of this equals natural log of this, if the natural logs match up, then their inputs, their insides, must also match up. Okay? So we're never dividing by log, but we can get rid of the logs now. So I'll multiply this out. That'll be 2x squared minus 4 minus 3 minus 7x plus 6 equals x squared. So now we just have a quadratic to solve equal to 0 and factor. One of our most powerful equation solving tools, equal to 0 and factor. And so we get x equals 6 and x equals 1. Okay. So you're probably feeling pretty good. Did some stuff with logs there, used log properties, solved a quadratic equation, did some algebra, got some answers. Seemed like nice simple answers. However, this is not the correct answer. One of those answers does not actually work. We've got an extraneous solution here. So you might remember we had extraneous solutions before with when we had equations with fractions because you can't divide by 0. The denominators can't be 0. When we had roots, because you can't take the square root of a negative. With absolute value, because absolute value ought to have to equal positive. Whenever we had things that had restrictions, there's the possibility of an extraneous solution. Well, there was a restriction with logs. Okay? Again, what we said back here is that anytime you're taking the log of something, and I have natural log here, but it would be any log base, okay? Any kind of log, whatever you're taking the log of has to be positive. Okay, well, let's take a look at what would happen here. Let's say that we plug in x equals 1. If you plug in x equals 1 right here, you're going to be doing natural log of -1. As soon as you see that, you're done. Extraneous solution. It's not actually a solution. We didn't do anything wrong. We didn't make any mistakes. We just got an extraneous solution that doesn't actually solve the problem. Okay, with 6, when I plug it in here, that's natural log of a positive, natural log of a positive, natural log of a positive. I'm good to go. Okay, and notice we do have to check it in the very original step here before we use log properties. Okay, back at the very beginning is where we have to check it. So we've got one more thing we have to add to the list of when we always need to check for extraneous solutions. If there's fractions, if there's roots, if there's absolute values, and now if there's logs. Always check your answers. See if you get something that's extraneous.